Good morning, friends. Today we are going to demonstrate one practical known as wave shaping circuits. In that, first we are going to demonstrate negative clipper. So we have a experimental bodies here. First one you can see here, this is the input portion and this is the output portion. In the diagram we have a diode, and at the output we have a resistor here, and to the input we will be giving sine wave. So that is given from the function generator. Here is the function generator. Here the CRO probe is here. We can see this transparent wire is positive and the black one is negative. So that is, first it is connected to the output junction is here. Here it is connected, and the positive one that will be connected to the positive of this network. The negative of the probe will be connected to the negative of the network. First diagram. Okay, that is done. Now we have to see the output. For that we will be using the CRO. CRO is here. You know, I think you might have seen this instrument earlier. So this is having two channels. We will be using one channel for visualizing the input, and the another channel we will be using for visualizing the output. So first we will connect the CRO probe to the channel 1, and again this is another CRO probe having a transparent wire. This one is positive and this one is negative. So, both the probes are here. So this we will use, channel 2 we will be using for visualizing the output. Positive of the probe that is connected to the positive of the output, and negative of the probe that will be connected to the negative of the network. So that we have given for visualizing the output. At the same time, we have to visualize the input also. For that we are using the channel 1 of the CRO. So this is the positive. Positive will be connected to the input of the network. So here is the input. So same wire I can give it here, or I can give it here also. If you have another wire, you can give it here, otherwise you can directly connect to this. So that means this probe I am using for visualizing the input. So you can see on the CRO we are getting a sine wave here. Okay. So here I have adjusted the frequency of this sine wave as 500 hertz almost, and some voltage also we can adjust. We can increase or decrease the voltage of this. We can vary the frequency of this. Frequency we can vary this. That way we can do. We can usually we give 1 kilohertz. We can give a 1 kilohertz frequency. We can give for this, almost 1 kilohertz. Now this is the input. What we are going to give at the signal we are going to give at the input of this negative clipper. So let us see what is the output. Is it okay? So I think the CRO screen is visible, I think. See what happens here. In the input we have both the cycles, positive and negative half cycle. The output we are getting only positive half cycle. The negative half cycle is clipped off. That's why it is known as negative clipper. Why it is happening this, that you can see from the diagram, that we are giving a full sine wave here at the input. During the positive half cycle of the input signal, the diode, the polarity is given here. You can see the symbol polarity. The left side is positive and the right side is negative. That means during the positive half cycle, the diode is forward bias. So the diode will conduct in the forward bias condition. So current will be flowing through this and it will be flowing through the resistor. So we will get the positive half cycle at the output. But when the negative half cycle comes, the diode becomes reverse biased and there is no current flowing, current will not be flowing through the diode, or it will not be conducting. So, we will not get any current through the resistor R. So, we will not get any output. That is why that portion is clipped off. Okay. So, that is the experiment. The remaining, we have other experiments also like positive half cycle, and that also we can do the same way. You can just do this positive half cycle. For that, again you can take the output here. To get the positive clipper, we have to just change the polarity of the diode. The remaining everything will be same. You give the input, take the output, see the waveform. The positive half cycle has clipped off. Here what we have done is the polarity of the diode has just reversed. So, the same principle you can apply here. During positive half cycle, the diode is not conducting and we are not getting any output. That is, positive part is clipped off, that is, it is a positive clipper. First one was negative clipper. That is, the diode is connected in series. In the lower portion you can see the diode is connected in parallel, that is shunt. It is in shunt. The same thing we can do here also. Same thing you can see here. Give the input, take the output, take the output. Again, this is positive clipper. Now, this is negative clipper. When the diode is in the parallel connection, that is all. Thank you. In this video, I am going to explain clamper circuit. You know, there are two types of clamper circuits, positive clamper and negative clamper. In this circuit, we have got one capacitor and a diode connected like this. When the signal is given at the input, because of the charging of the capacitor, some DC level voltage will be added. That is why it is clamped. Either it will be clamped upwards or it will be clamped downwards. If it is clamped upwards, that is positive clamper, and if it is clamped downwards, it is negative clamper. That is, because of the charging of the capacitor, the DC level is added. That you can see when you are doing the experiment. I will demonstrate it how it is clamped upwards and it is clamped downwards. So, let us move to the experiment part. Here on the board you can see input portion is there. Here we will be connecting the function generator, and the other part is having a capacitor and a diode with a polarity like this. The upper side is negative and the lower side is positive, and let us connect the function generated at the output using CRO probe. Positive of the CRO probe is connected to the positive terminal and the negative of the probe is connected to the negative of the network. Now, first we will visualize the input signal whatever we have given at the input. For that, you will be using the CRO and the CRO probe. As you know, the positive of the CRO probe is connected to the positive of the network, and the negative of the probe will be connected like this. So, here you can see the waveform, the sinusoidal signal which is given at the input of this clamper circuit. It is given from the function generator with a frequency of 975 Hertz. It is almost equal to 1 kilohertz sine wave we are giving. Now, on the CRO, when you are visualizing the output, you have to consider you have to put it in the DC mode, because DC voltage is also added here. You have to put it in the DC mode. We don't keep it in the AC mode. For that, here there is a button here. You have to press it. That means you are using a DC mode. If you release this, that will be AC mode. So you have to keep it for DC mode. Then you go to the output. Keep the same probe to the output. You can see that the signal has clamped upwards. It is clamped upwards because of the addition of the DC level, that is due to the charging of the capacitor. See here again I can show you. This is the input signal, and this DC level, or this one you can use it as the reference. Reference we are keeping at the center of the sine wave. So now the input signal, it is like this. Positive half cycle is on the top of the reference line, negative cycle is on the bottom of the reference line. That is the input. Now when it is clamped, or the output of the clamper circuit, it is a positive clamper, that will be clamping upwards. That's why it is moving towards the upper side. It is clamped with a some DC level voltage is added to that. That's why it is gone to the upper side. That's all. Now the same thing can be done for the negative clamper also. You just give the input signal, same signal, give it to the input of the negative clamper. Here what you have done is, the only change is the change of the polarity of the diode. The polarity of the diode is reversed. The upper portion is positive and the lower portion is negative, while on the other one it was in the reverse. Now again the same input we are giving to the input of this negative clamper. Let us see the output. It will be clamped downwards. So it has clamped downwards. You can see on the CRO screen. That's all. Thank you.